This lesson is on 5.3, writing proportions. So we're going to write proportions and solve for proportions as well in the examples that are going to be given. So in the first problem, we're already given the proportion and we need to solve for this. So we look at the first fraction. We have 3 divided by 2 is equal to x divided by 8. And we need to figure out what is x. We're saying that the first fraction is equal to the other fraction. If that's true, I see a pattern. If I multiply 2 by 4, that would give us 8. So then that could be a true statement for the top part, for the numerator. If I multiply 3 by 4, then that should give us 12. So the new fraction will give us is 12 over 8. Now, I chose 4 on the numerator and denominator because then it's multiplying, you're technically multiplying by 4 over 4, which does not change our fraction because 4 over 4 is equal to 1. But also to check yourself, if your result is 12 over 8, you can simplify 12 over 8 if you divide it out by 4. And so 4 goes into 12 3 times, and 4 goes into 8 2 times, which is exactly the same fraction that we have right here. So that checks right there. Now let's look at B. So if I have 21 over 24 is equal to x over 8, I could do the same thing and say 8 times something gives me 24, or I can try to simplify that first fraction right there and see if we can work with a smaller number. So in the first fraction, I can see that the pattern is if I divide by 3 on both the numerator and the denominator, that will give us a smaller number to work with. So 3 goes into 21 7 times, and 3 goes into 24 8 times. If I rewrite the second part of that fraction, then I could see, 8 times 1 gives me 8, then 7 times 1 should give me 7. And so that makes sense because 7 over 8 should equal to 7 over 8. That's a true statement. But if you did it the other way, you could multiply 8 times 3 to give you 24, and then you would have to think about what number times 3 will give you the 21. So you could work with different ways, but these are number senses that you have to think about working on these proportions. Now let's look at example 2. So example 2 says that we have a table and we're going to write a proportion. So with working with a table, this purchase part right here and the total cost, as long as they're the same units across this direction and across this direction, then we actually have our fractions set up. So our first fraction should be 2 over 6 and should equal then to 3 over x, because the numerator on the top part are purchases numbers and the denominator numbers are going to be the total cost. So again, similar to the previous practice of examples, we're going to look at 2 over 6 and try to figure out what is equal to 3 over x. So if we simplify 2 over 6, I can see a pattern that I can reduce by 2. So then this will become 2 goes into 2 one time, and 2 goes into 6 3 times. So if that's true, then fraction is equal to 3 over x. So then I can say 1 times 3, right, gives me 3. Then 3 times 3 should give me 9. And so 9 should be the fraction. So if I go back, I can always check it to see if that's true. So my fraction now becomes 9 right here. A 2 over 6 can be simplified as previously the 1/3 right here. So we can say 1/3 and then is equal to the 3 over 9 right there. And 3 over 9 can be simplified further, right? So we can divide it out by 3 and that should give us the 1/3 as well. So then we are saying then 1/3 is equal to 1/3, which is a true statement. So you can always go back and check your fractions to see if it's a true statement. Now let's go ahead and look at our last example. So last example is example 3. It says write a proportion to find how many hits each a player needs to achieve the given batting average. Then solve the proportion. So the batting average formula is given for us right here, and it says that it is hits divided by at-bats. So when a baseball player goes to bat, that's the denominator number, at-bats, but the actual hit is the numerator number, which is the H right there. So if we're given that the baseball player has 84 times at bat, that's the denominator number right here, so 84, and then the average is 0.250. So what we're looking for is the number of hits that this baseball player actually had. So to get the number of hits, the x, we need to multiply by the denominator number, 84, on both sides. So let's do that in parentheses actually. So 84 over 1. So that this part right here becomes 84x over 84, which the 84 turns into a 1. So you can see the reasoning for that right there. And then on this side, then we do 84 times the 0.250 right there. Okay, so let's do area modeling. So I'm only going to use the 25 right there. So let's do the 25 instead. So let's use area modeling of 25. So 20 and 5. And then we use the area modeling for 84. So there's 80 and 4. So 8 times 2 is 16, and we have 2 zeros, 1 and 2 right here, so we're going to add 2 zeros. 8 times 5 is 40, and we have 1 zero from the 80, so we add that in there. 4 times 2 is 8, and we have 1 zero from the 20, so we add that in. And 4 times 5 is 20, so that gives us there. And then we're going to go ahead and add all the numbers together. So 1600, and give yourself enough space so that way you're adding all the numbers in the right columns when you stack them up. Okay, so the first column will give us 0. The second column, 8 plus 2, gives us 10, so there's a 0, carry 1 over. 6 plus 4 is 10, plus the 1 that gives us that will give us 11, carry 1 over. 1 plus 1 is 2. And since I only use 25, I'm only going to move it to 2 decimal places. So from the back, we're going to move 2 decimal places over. So that's 1, 2. So 21 is going to be the number right here. And so that means this person actually hit 21 times right there. So those are the practice problems that we'll be working with.